It's time to learn day 2 of U sub. They get a little more complicated today, so pay attention. Okay? Today we have to make a change of variable. You have to do a double U sub. All right? So I'm going to let let u equal 2x minus 1. And du is equal to 2 dx. So dx equals du over 2. And now I'm going to make my substitutions. So I get the integration of x, and I have the square root of u, and then I have du over 2. The problem is I still have this x in there, and you can't integrate with two variables. All right? So what I'm going to do is solve this for x. So you get u minus 1 equals 2x, or x equals u minus 1 over 2. And now I'm going to substitute that in, and my integral, let's go back to purple, becomes u minus 1 over 2 times the square root of u du, and I can put that 1/2 out front. All right? Actually, I can pull, hang on, time out. We're going to leave this here, and that was over 2. And I'm going to rewrite it one more time and pull both those out, so I have 1/4 out front. I have u minus 1, and I'm going to rewrite u to the square root to u to the 1/2. All right, and then you're like, wow, this is ugly, ugly, ugly. But it's doable, because I can distribute, and you get u to the 1 plus 1/2 is 3/2, minus u to the 1/2 du. I can find the antiderivative of that. So you have 1/4. You add 1, so it's u to the 5/2, divide by 5/2, which is the same as multiply by 2/5. And this becomes u to the 3/2, and you divide, ooh, that's a minus, isn't it? That's, my notes are bad. And you divide by 3/2, so this becomes 2/3. And let me go back and fix that, make it a minus because it was a minus. Okay? And you're done, plus c. Whew, huh? So you had to, you have this extra step in here right there. All right, let's do this one. This one's a little different. And what I do is I let u equal 1 plus the square root of 3x. And I change it to u minus 1 equals the square root of 3x. And how do I know to do that? Because I've done this before, all right? Because now I'm going to take the derivative of this. But first, this is u minus 1 equals 3x to the 1/2. The derivative here is du. This is 1/2 times 3x to the negative 1/2 times 3. If I clean that up, you get 3 over, plus dx, sorry. So you get 3 over 2 times the square root of 3x dx. And when I solve for dx, you end up with 2 root 3x over 3 du equals dx. Ooh, that was complicated. Now I'm going to make my substitutions. And you'll come back and you'll see why we did this. All right, so let's change colors. So here's my substitution. I have 1 over u. I replace dx with 2 square roots of 3x over 3 du. You're like, well, that's still ugly. Well, right here, we have the square root of 3x is equal to u minus 1. So I can, first place, put my 2/3 out front. I have 1 over u still, And this becomes 2 square roots of u minus 1. Okay? Oh, not the 2. The 2's not there, sorry. So take out the 2. And there's no square root. Well, here you go. Let's replace that too. Because I replaced the square root. This should be just u. All right. Now, we've got 2/3. We've got u over u minus 1 over u. So that's 1, right? Now, if you take the antiderivative of 1 is u, minus 1 over u, which is the natural log of u, plus c. And then you got to put your x's back in. So this becomes 2/3. U is 1 plus the square root of 3x minus the natural log of 1 plus the square root of 3x plus c. Plus c. All right? Yeah, that was hard. You might want to rewind and listen to that one more time. And the question is, how did I know to do this? Because I've done it before. I probably worked it and had to rework it to find that out. All right? All right, here's the rest of trig. Things you just have to memorize. These we already knew. Okay? These are new with this natural log in there. And I want to work this one because it's like, what did they do? Just pull it out of the air to come up with that kind of answer? No. What you do is you change this integration to the sine of x over the cosine of x dx. And you let u equal the cosine of x. So du is equal to the sine of x, negative sine of x dx. Oh, there's too many n's in there. So dx is equal to du over negative sine of x. You make your substitutions. You get sine of x. You have u. You have du over negative sine of x. These guys cross out. And you end up with negative integration of 1 over u du, which is negative ln of u, and u was cosine, plus c. And there's your answer, okay? And you can do that same process for the rest of those. But I think it's nice to know, all right? Next, we're doing definite intervals with u sub. The problem is you need to worry about these bounds. Okay, the bounds are the issue. Okay, bounds. Worry about them. So I'm going to do the same thing. U is equal to x squared plus 1. Du is equal to 2x dx. Dx is equal to du over 2x. I'm going to make my substitutions. So I have x. I have u cubed du over 2x. The x's go away. I now have 1/2 integrate u cubed du. The problem is the bounds, okay? These bounds are in terms of x, okay? Those are in terms of x. In terms of x. We need to turn them in terms of y, of u. So what I do is you plug it in here. So you have 0 squared plus 1 is 1, so this one becomes a 1. And this was a 1, so 1 squared plus 1 is equal to 2. So I'm going to integrate from 1 to 2. Now they're in terms of u. Okay? Now, take the antiderivative, so u to the 4th over 4, and I'm going to evaluate it from 1 to 2. So I have 1/2 times 2 to the 4th is what? 16 over 4 is 4 minus 1/4. and you get 15 over 8. I'm pretty quick that way. Okay, your other option is go down here is 1/2. Put your x's back in. So you have x squared plus 1 to the 4th over 4. And you evaluate it at the original bounds, 0 and 1. And since you have a 0 in there, it's not too bad. So you have 1/2. 1 squared is 1, so you have 2. 2 to the 4th is 16 over 4. Oh, sorry. And then you have to subtract, sorry. You put in 0 and you get 1/4. And you end up with 15 over 8, and you get the same answer. Okay? So here you left the u and you use the bounds in terms of u. Here we put in the x and you use the bounds in terms of x. So pay attention to your bounds. Let's do one more. I'm going to let u equal the square root of 2x minus 1. You're like, how did you know that? Same thing. I probably had to work it twice. Okay? I'm going to square both sides, so I get u squared is equal to 2x minus 1. And then I'm going to solve this for x. So I have u squared plus 1 over 2 equals x. And I'm going to take the derivative of both sides. So the derivative is, well, let's see, let's split this up. U squared over 2 plus 1 over 2 equals x. The derivative here is u, oh, that's fun, du. All right, so come back up here, make your substitutions. I didn't do my bounds yet. So I have x over u, and I've replaced dx with u du. I mean, u du. Is that right? Yes. All right, now what happens? The u's cross out, and I've got the integration of x du. Well, correct. So I need to replace the x with what it's equal to in terms of u. So now I have u squared plus 1 over 2 du. And I'm going to take the 1/2 out front, so now I have 1/2 integration of u squared plus 1 du. And I didn't do my bounds yet. So here's my bounds. We're 1 and 5. So if you plug in 1, you get 2 minus 1 is 1. The square root of 1 is 1. And if I plug in 5, I get 10 minus 1 is 9. The square root of 9 is 3. So those are my new bounds. Okay? If I take the antiderivative, you get u cubed over 3 plus u. And I evaluate it from 1 to 3. So I get a half times 27 over 3 is 9 plus 3 minus 1/3 plus 1. And that's obviously, that equals 16 over 3. Don't you like how fast I am? Trust me. Stop, pause, get your calculator out. Your other option is, once you get here, replace your u with what it was equal to, square root of 2x minus 1 cubed plus the square root of 2x minus 1, and you're going to evaluate it from 1 to 5. And I believe you get the same answer, okay? That's going to equal 16 over 3 also. So pay attention to these bounds. I went from 3 to 1 and I left the u's in there, or you go from 5 to 1 and you put your x's back in. Either way will work. Show your work. And that's all there is to day 2 of integration. And things like, how did I know, how did I know to do this? Practice, okay? And to solve, go around and solve for x. Before I took dx, practice, okay? This one was pretty straightforward, u sub. This one's the same thing. It was just practice. I've done it enough times, and I got to a point where it didn't work, so I had to go back and try something else. Good luck. Practice, 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 y'all.